Hey guys, here is a video with the notes and examples for how to do algebraic proofs. The good news is the majority of this you already know. It's just a matter of how you present your answers. Alright, so I'm just going to kind of describe what all this is. I'm not just going to read it to you. You have it. You can read it when you want. But the basic idea is you're going to be solving an algebraic equation like you normally would, but you're going to actually describe what it is you're doing. For example, in this equation here, the 3x minus 4 equals 2x plus 1 is what we were given. Okay, so I just wrote it out. This is the original equation which was given. Then what you might do, depending on how you approach it, you might have added 4 to both sides to kind of get this over to, to the right hand side. So you would say for this step I added 4 to each side of the equation. And then most people from there would just subtract the 2x from both sides, and you say you subtracted 2x to get your final answer. Alright, now if you're saying, oh man, that's a lot of wording, I don't want to have to write all that every time I do a problem, I totally understand. So we have a streamlined way to do it, and we call this a proof. And I'm just going to kind of slide down here to show you what it looks like. This is the basic structure of your proof. You're going to have your statements, which is exactly what you would do, the old-fashioned way, where you just sort of solve. But you also have a column for your reasons. And your reasons are just a formal way of saying exactly what you did in your statements. Here are examples of the different reasons you can use to start out. There are other reasons we're going to get to as well, but these are pretty much the algebraic ones. So if you look at the same example we just did, you start out with simply just the given. You always start with your given. And then we added 4 to both sides, so we used the addition property. And that's all you have to write. Then you subtracted 2x from both sides, and that's the subtraction property. Okay? Okay, sorry about that. My phone had just rang. So you're just using the reasons, the basic algebraic reasons, to justify each step. So somebody might say, well, Mr. Miller, what if I didn't add 4 to both sides to start? Maybe you wanted to subtract the 2x from both sides to start. Okay, well, I did it that way too. So your first step, the way you did it, was subtract 2x from both sides, and this is what you would have ended up with. Well, guess what? You used the subtraction property first. That's okay. As long as you don't break any algebraic rules, it'll still work, and you just have to justify what you did. Then you added 4 to both sides, and we both still got 5, but that time you ended with the addition property. So the only thing that changed was our order changed. And again, as long as you don't break any of the algebra rules, you follow your normal routines, you just have to give a reason every time you make one of your steps. Okay, and that's the basic idea. All right, here's another example. Okay. So this is your equation that they're trying to get us to solve. So that's what's given. All right, they're giving me this equation. And then since there's terms on one side of the equation that could be combined, that's what we're going to do first. So 8x minus 3x is 5x. And the reason you would give, if you look back at the chart, and these you might know these already, but this is just where they're listed. We have combined like terms. That's a choice. And that's what we did here. I'm not saying subtraction property here, because subtraction property is when you subtract something from both sides. So think back to algebra, or even, it might have even been pre-algebra when you learned that. When you use these properties, it's when you apply something to both sides of the equation. When we're just combining on one side, we just say combine like terms. Alright, now we have a situation where we can go to one side or the other. Looks like I subtracted 2 from both sides here, so I used the subtraction property. Then I subtracted 9x from both sides. I used the subtraction property again. And then to get x all by itself, I had to divide by -4, which is the division property. Now, somebody I'm sure is out there looking at this saying, Mr. Miller, shouldn't I have to write, like under here, shouldn't I have to write -2 and -2? You certainly can, but I think we've done enough of these at this stage where you don't need to necessarily show that. If you feel like you want to and it's helpful, by all means, go ahead, but you don't need to. Okay? Again, as far as the order of how you did things, I could totally see somebody going in a different order. Just make sure everything has a reason no matter how you do it. Alright? And then I have one more here, sort of an example to walk through. You've got this as your given, right? 4 times the quantity x minus 3 equals x plus 3. And hopefully the first thing you think to do here would be to distribute. Okay? So we're distributing the 4, and again, if you want to draw it, you certainly can. You're distributing the 4 to the x and to the -3, and we use the distributive property. And again, all the properties you're going to need in the beginning here are in this box. So if you have this handy, it'll help you. And if you're ever not sure what you're doing, just, as far as which property to use, just ask yourself, what are you physically doing to the equation? Okay, what are you actually doing? In this case, hopefully in your head, you're like, okay, I'm distributing. And then you realize it's the distributive property. What do we do next? Looks like at that point, I subtracted x from both sides. Well, that's the subtraction property. Then I added 12 to both sides. That's the addition property. And then I divided by 3. That's the division property. Okay? So these are the examples kind of done out for you with all the reasons. Let's try one where nothing is shown just yet. Let's do one of these and we'll see how it goes. 3x minus 5 equals 13. That's given. So your reason, you literally just say, is given. Well, now what? All right, what would you do next? Well, 3x minus 5 equals 13. Looks like I'm going to add 5 to both sides. So that's 3x equals 18. And what did I do? I added 5 to both sides. That is the addition property. And then how am I supposed to get 6 out of this? Well, it looks like if I divide both sides by 3, I'll get 6. Well, what did I do? I divided, so that would be the division property. Okay? Now, the rest of these, I gave you, the amount of steps it kind of should take, but take whatever steps you feel you need. Try those out. On part B here, you're actually going to set up your own proofs and come up with as many steps as you think it should take, but you're basically trying to prove that solve the equation x minus 3 equals 4 with all the steps based on using the various properties like I said at the beginning. Okay, all the answers are there for you. You can check your work. If you have any questions, by all means let me know. Have a great weekend.